Okay, so last year in secondary 1, you spent some time talking about congruent figures, right? So do you remember like side, 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 side angle, side, right? We're going to be doing that again, not today, but next time. Last year in secondary 1, you should have talked about congruent figures. Now, congruent figures are exactly the same, right? So a penny is congruent with a penny, but a penny is not congruent with a quarter because the quarter is bigger, right? This year we're going to talk about similarities. Two shapes are similar if they have the exact same shape, but maybe different sizes. And one way we check for similarities is by setting up proportions. Now a proportion is where you have two fractions that are set equal to each other. That's called a proportion. To solve proportions, I think you've done this before, verify, cross multiply. To solve proportions, does that ring a bell? Okay, so here's how here's how you do it, and this is why this works right here. A proportion is just a fraction, right? And in a fraction, you generally have to get rid of the denominator, correct? So if I were trying to get rid of b, what would I do? I'd multiply by b and I'd multiply by b. So what I'm trying to do here is to show you why the cross multiply works, and after that we'll just cross multiply. Is that okay? So if I multiply b, those would cancel. You'd be left with a equals ab over d, right? Now if I wanted to get rid of the d, what would I do? I'd multiply by d, and those would cancel, and I would have ab equals bc, which is what I have right here, right? So that's why the cross multiply works. So for problem A, when I do the cross, it doesn't matter which one you do first. I generally like to do the one that has the variable in it. That way the variable is on the left. So 3 times x would be 3x. Eight times 8 would be 64. Divide both sides by 3. X equals 2, 1, 21 point what? Why did I divide by 3? Because it was 3x. Oh, okay. Did I get too fast? Yeah. Now, that point 3, it's pretty obvious that that repeats, right? So if it repeats, I'm going to put the line over it. If it doesn't repeat, I'm just going to round it to one decimal spot. Okay, let's do it again. So cross multiply, I like to do the variable first. 5 times n. 2 times 6. 12. How do I get rid of the 5? Divide by 5. There are going to be some pieces on this assignment that the work part of the math, some of you can do in your head. As long as you write at least one of the steps down, I'm going to call that enough for showing your work. Like, that's fine with me. But you have to write something down. 12 divided by 5 is 2.4. Okay, for the next one. For the next one, all on your own. X equals 42, right? Jackson, how many calculators do I have in there still? Am I running out every day? A lot or a little? A lot? We're good? Okay, we're good then. 8.4, is that okay? What happens when I have this 3 right here? Yeah, when we cross multiply, the 3 and the 8 get multiplied together, 3 times 8, 24x equals 24. Very good. Again, review-ish, I hope. Yes? Good. What happens then when I have a plus? It's not just a 3x, it's a plus something. What do I do now? Well, I'm going to cross multiply still. When I multiply this over here, I would have to distribute through, right? So this would be 12x plus 12 equals what? 4. Is that okay? We're going to distribute through. Because when I multiply this 12 over, I have to multiply the x by 12 and I have to multiply the 1 by 12. To add in this. Subtract the 12. 12x equals -8. Divide by 12. X equals -4. No, it doesn't. No, it doesn't. Kidding. X equals what? 4 goes into it. I think that's where it was going. -2/3. If you want to change that to a decimal, you can. I really don't care which. Sorry about that. Are you okay with this? Feeling good? Like, yes, I know how to do this. Let's keep going. What about the next one? I've got variables on both sides. Is that okay? Yeah, it doesn't really matter where you start. Maybe we'll start with the harder of the two. When you cross multiply there, what do we get? Okay. On this side, so subtract the what? If I subtract the 4x over, then there's nothing left right here, and people get really confused when that happens. So let's subtract the 5x. Now this also is a really easy place to get confused. If you have -15 equals -x, how do you solve for x? So x equals 15. Perfect. Okay, so now we're going to start talking about similar polygons. Similar polygons are used in real life, or the idea of similarity, I guess, is used all the time. So, for example, like Lord of the Rings. I know it's kind of older now, but when they made Lord of the Rings, in that first movie, you know, raise your hand if you've seen Lord of the Rings, so not just... Okay. Some of you have seen Lord of the Rings. So at the very beginning, they talk about going and meeting the elves in Rivendell. Is that it? Okay. So they talk about, and the hobbits are like, let's go to the elves or something. We're gonna go meet the elves or something. They get really excited. And so the camera in that movie pans around where the elves live in Rivendell. And it's like this beautiful land, right? This beautiful land where these elves live don't actually exist. So what they did, the producers, creators, whatever, in their studios, they built these giant scale models, and then they used a scale factor, or the idea of similarity with their cameras, to make these cities look real. But in fact, they're just these miniatures. They call them bigatures because they're so big. Usually they think miniatures as like tiny, right? But it's like huge. But it's still a miniature model of this real place. So the idea of similar polygons are used. And today we're going to talk about how you... Today we're not necessarily going to talk about how you test for them, but we are going to talk about if they're similar, what can I do? So, a couple things to know about similar polygons. The first is they have the same shape. Do they have to have the same size? technically, I guess they could, but then they would be, more specifically, they'd be congruent. But one could be bigger than the other. So question, two circles. Are two circles always similar? Two circles. Is that like a quarter versus like the half court, you know, circle at the half court in basketball? Are those similar? They're not the same size, clearly, but are they the same shape? Yeah, they're both circles, right? So they have to have the same shape, not necessarily the same size. In order to test for shape, you're going to test for two things. You want to see if all of the angles are the same. Which means, like this angle right here, this angle right here, and this one right here, they would both have to be exactly the same. If one was 74 and the other one was 75, I would say they are not similar. This angle and this angle have to be exactly the same. And we'll get more into that next time. The other thing that you need to know is all angles are the same. And then all sides are proportional. Now, a proportion is what we just did above, right? Where we have two fractions that equal to each other. So if I give you two shapes, whether it be triangles or just a polygon, and ask you, or tell you that they're similar, that means I could set up a proportion and find missing sides. Now, if this was 5, and if this was 10, say this was 1, how big would this one have to be? 2, because this polygon is twice as big, right? That number, twice as big, or we could go reverse, this one is half as big, right? That's called scale factor. The scale factor is how much bigger or smaller one polygon is to the other. Now, how do I know if I say find the scale factor, how do I know if I'm talking the small to big or the big to small? It will tell you in the problem. And what I mean by that, I'm going to get to in just a second. So if I were doing this example, it would say something like, write the scale factor of the polygon from the small to the large, or something like that. Really quick, a scale factor is a ratio. Add that in there. So if I were trying to find the scale factor from the small to the big here, I would put the small number, so we're going to call it 1, and the 1 matches up with what? The 2, it's half as big, so that would be the scale factor for this particular example. 2 over 1, exactly. Almost always it's going to be like this, but I'm not going to say always. It will tell you though in the problem. Space, enlargement versus reduction. If I'm starting here and I'm going here, I've made a what? I've made an enlargement. This is kind of obvious, right? You've been doing this for a while. So in enlargement, they're going to be made bigger. The reduction, it would be made smaller. Okay, cool. Moving on. So, number 2, the polygons in each pair are similar. Find the scale factor of, tells me what to do. The smaller to the largest. So here's how I do this one. I have a bunch of different sides, of this triangle, right? I have the 14, the 12, the 24, the 21, the 18. First of all, which one's the smaller triangle? The 14 one, right? So I'm going to put, when I make my fraction, my scale factor fraction, I'm putting this number on top because it's the smaller and I have to do small to large. I don't know yet. But this triangle goes on top, this triangle goes on bottom. Oh. Now, how do you know which numbers to put together? Well, 12 is the smallest side, right? On this one, which one's the smallest side? 18. Okay. Those two are a match. 14 is kind of your middle. 21 is your middle. Is that okay? And then 24 with whatever that would be. It doesn't matter which two numbers go in your fraction as long as they go together. So I'm not going to use 24 because we don't know this one. But I could put the 12 over 18, or I could put 14 over 21. How do I know which one's right then? If I simplify them, good, what's going to happen? Try to simplify both of them. 12 and 18 are divisible by 6, so you have 2/3. 14 and 21 divisible by 7, so you have 2/3. Because they're similar, the scale factors, right here and right here, are the same. So it doesn't matter which match you put together, it's going to be equal. Does that make sense? Okay, let's look at part B. So write the scale factor from small to large. Which triangle will go on top? This one. Good. This means this one has to go on bottom, right? Now, this 120 matches up with what? Now look at the 120 right here. Does it look like the longest side? Well, it's bigger than 100, so now compare these two. Compare these two. Is 120 larger? Yeah. So I know 120 has to be my biggest. Looking at this, which one's my biggest? 36. That means I don't care at all about the 100, the 30, or the 24. If I want to write a scale factor, I could say 36 over 120. Simplify it, and then we're done. A scale factor is a ratio, so you could leave it like this, you could leave it like this, but we don't usually leave it like that. I do not want to leave it as a decimal, is kind of the big thing. So scale factor should be a fraction. What goes into 36 and 120? 12? Yeah, no, good, 12. I'm good, 12. 36 divided by 12 is 3, right? 10? Good. So what about this one? Which two will match up? Obviously this one's on bottom, or top, this one's on bottom. Should I put the 5 on top or the 7, or does it not matter? Doesn't matter. 5 on top, 20 on bottom, because they go together. Divisible by 5. So my final answer, 1/4. So again, tell me one more time what the scale factor is. Scale factor is how much smaller one is from the other. Okay, cool. So now we're going to use proportions to find the missing lengths of the similar polygons. The first thing what I want to do is we need to write a proportion. Now, this 11, does it look like the short side or the long side between those two? Probably the short side, is that okay? Now the 22 versus 28, 22 is the short side, so those two will match up. When I write the proportion, they go together. It doesn't matter which one goes on top, which one goes on bottom, but they go together. Keep going. That means the 28 and the question mark would go together, right? Yep. So this time, you are creating the proportion. So it doesn't really matter which one you put on top. The time before it did because it told us, right? But in this particular problem, when you're the one writing the proportion, it doesn't matter which one goes on top and which one goes on bottom. So I marked it so this triangle goes on top. So I'm going to put 22. If I start with 22, what will go underneath it? 11, because they're together. They're called corresponding parts, corresponding sides. If I put the 22 on top, what goes in this space? 28. My last class said this wasn't new. This is kind of a review. Do you agree? Have you done this before? I remember teaching it before the core changed to my middle school kids, but again, that was before the 14, so I don't know. 22 times x, 22x. 11 times 28, 300. Divide by 22. Very good. So if I were to explain to whoever's not here what to do, I would say the first step, look for those corresponding parts. Second step, put them into a proportion. Third step, solve, right? So 18 matches up with what? 18 with the, oh, this is, by the way, where I'd be using the colored pencils, if that helps you to, like, shade them in or color it so you know which one goes with which. If coloring, the color doesn't help you, then don't worry about it. There's a lot of different ways that we have learners, visual learners, color help, or whatever. 18 goes with, yeah, I mean, just look at them, the 48 and the question mark. This one looks smaller. Sometimes. Depends on how. It could be, not always. Which means the 24 goes with question mark. Now there's about 3 different ways you could set up the proportion. So this very first step could be different depending on who does it. So when we cross multiply, that's when everybody should be on the same page. If I started with the question mark on top, what goes underneath? Good. When I cross multiply, I'll call that an X. Okay, what goes on top right here? The question mark started on top, so 48 has to be on top. Because this triangle started. And this triangle ended. 48 over 18. Again, yours could look different. But when we cross multiply, 18 times x is 18x. 24 times 48 is 1,152. Thank you. Divided by 18. Good job. Questions with that? How do you feel about it?
So how would you, I just think you enjoy having the title. I was trying to see how you feel like that.
Which part? How did I set up the Are you okay with which piece goes with what? Kind of, not really. Okay, let's look at this one then. Sometimes I just find that rather than backtracking, going forward is a little bit more helpful. So let's look at this one. Now, this time, this time the triangles are kind of merged into one, right? So if I have a problem like this, I see, look, is this question mark the entire side of the little triangle? Like it's PU, right? That question mark is from here to here. That's okay. Is the 100 2P? Yes. So I've got one side, right? They're going to go together. One's going to be on top of the other. One's going to go on top of the other. It doesn't matter which one goes on top, but one of them will. Now, depending on where I start, dictates what's going to go up here. So if I started with 100, what would I start with on this side? 90, because 90 is the big triangle. And then the 27. So I started with 100, it's the big triangle. I need to start with 90, the big triangle. Below the 100, I put the X because those are corresponding sides. They go together. So I need to put one underneath there. 27. Does that help a little? So now you want to try part C, right? To try something when it's not together. Okay, cool. Let's finish this one. 90x equals, you probably got it. You're just a little unsure. That's my guess. Divide by 90. X equals 30. Very good. Okay, try part C then. Let's just see if we can figure out what goes with what. know, these aren't always given, but here's another way you could like find out. To me, when I look at it, this 6 compared with this question mark, which one looks bigger? The question mark. You have to kind of trust the picture. They're very close, but I don't think that they're the same. The other way you can know though, this similarity statement right here, when we write them, they're listed in order. Angle F and angle L are the same. Angle G and K are the same. Angle J with angle J, those are vertical angles, right, are the same. So this question mark is in between the pink and brown, which means it goes with the number in between the pink and the brown. That's another way you can check it. The 6 is between the red and the brown, so it must go with the 12. It was bullet. Hold on. If it was something like that, that's possible. Or these would go together and those would go together. If it was in the midpoint, basically. Okay. Not necessarily the midpoint now. So it is possible. It would look a little bit more like these. Yeah, you could. Okay, so finish this one up. Looking at them, I've already marked what goes with what. Never ever do the way you did in here on top of the board. And then when you guys have that. Now her proportions could look a little bit different than yours depending on what number you put on top and what number times you started with. So when you cross multiply, it will come out the same. The big thing is the 14 and the x go together, the 6 and the 12 go together with an equal sign in the middle. Now you could have put the 14 over the x, right? But if you did, the 12 should be on top as well. Like the tops will go together, the bottoms will go together, and then each side will. Yeah. 6 times 14. 84. Oh. Good job. Okay, pass it off. Who wants to do the next one? Not okay. Don't answer that question. Pass it off. Now this one, there's a lot more going on, right? So again, your proportions could look different depending on the numbers you chose. Final answer should be the same. So the 10 over 20 is on the bottom, right? We started with 10, we had to go to 12. Cool. I love how you all choose your friends. Like think that you choose somebody that you didn't know so that your friends can be spared from coming to the board. But hey, more power. More power. Romans to fire. Last class I made them pick somebody that they didn't know their name and we got to know people's names, so you wouldn't do that again. No, they're very quiet. They're not weird. Very quiet. Besides, you guys say yes, I'm recording. They're very quiet. Pass it off to them. Good job. this game.
These other angles, these other numbers, like.
There was another way you could have done that. You could have done that with 14 and 28 as well, and still got the same answer.
You could have used
Or instead of 10 and 20, you could have used the 14 and 28.
that's more like it.
Over here.
Is that wrong? I don't know how to do it. How do you do this? I am. Sally? What? Oh, hello?
So, oh, this is a perfect example of the photo I think that I was just drawing, Elise.
Yeah,
Where he is the, yeah. How do you feel about this? Thank you. I'm going to back up just a little bit. These are all perfect answers. Going to this one. This 7, is that the short side or the long side? The short side, right? Now you have to just, well, you don't have to just guess because of this right here. But I think on your homework, will somebody confirm, are those letters written in? There is on 8, but what is not on 7? And then that's 8. Isn't that 2? Awesome. So there is a similarity statement, I think, on your homework. You could use that to help you. But look at the 14 and the question mark. Doesn't the 14 look smaller? Doesn't put it together. Likewise then, the question mark with the 10, they go together. So, now, it doesn't matter, 7, question mark, 14, or 10. Any 4 of those numbers could come right here. But then after that, everything else filled in doesn't matter. 7 matches up with the 14. The 10 matches up with this X. We're good here. We're good here. Let me show you the other ways you could have started this problem. You could have said, like you could flip them, 14 over 7. And if I did that, the 14 goes with the 7, what's going to come next? 14 and the, yeah. Is it possible to say 7 over 10? In this case, I'm just dealing with this triangle. If I said 7 over 10, what's the other proportion going to have to be? I start with 7, that means I start with 14, and then 3. That is an okay proportion as well. There's a lot of different ways to set these up. A lot of them are correct. The only one that would not work, let me show you this one. This one doesn't work. If I said 7 over question mark equals, the reason this doesn't work is the 7 deals with the small triangle, the question mark deals with the big triangle. That's okay. But is 7 and the question mark corresponding pieces? No. So this one would not work. It's the only one that doesn't. 7, 14, and then it would be 10. So 7 and 14 started. Then you have to go back to the 10 because this triangle is going on top. Because it's the same triangle. So it either needs to be corresponding pieces or the same triangle. Okay. Yes. Hopefully that cleared up a lot for you. Okay, now we're going to talk about dilation. Everything that's happening on this page is either an enlargement or a reduction, like it's getting bigger or smaller. A dilation is a little bit more specific, which is why there's another load of writing right here. I'll highlight what's important. First of all, dilations only happen on the coordinate plane. So it's a coordinate transformation. It's not on the coordinate plane, it's not a dilation. Is that okay?
So dilation can not be coordinate.
Right.
Okay.
Has to be on the coordinate plane. Now the image and the pre-image are similar to each other. So I guess if we were evaluating keywords, the image and the pre-image are similar. Yada yada yada. Something else that's kind of important, the shape, orientation, and angles are preserved, which means they stay the same. That means you're not going to have one image that looks like this, and then the other image that looks like this, because the orientation has changed. What is that? You can't see it. You're not going to have one that looks like this, and one that looks like this. Like they can't be rotated, is what I'm saying. In order for it to be a dilation, what you will see is one that looks like this, and then the other that looks like this, or something. That can't be rotated, that would be a rotation, yeah. So you'll see one, and then you'll just see an enlargement of the other. Okay. All sides changed by a single scale factor. I'll show you what that means as well. The corresponding image and pre-image sides are parallel, meaning that this piece right here is parallel with that piece. You'll see that in a second. And that's all we really care about. Those like three pieces. Everything else is a lot of math terms that you don't need to know. Okay? It saves you from reading that and understanding what it says. Okay, so what am I doing? Want that. So moving down. Use the origin as a center of dilation. All of yours will be centered from the origin. Plot the pre-image using points given. Then use a scale factor to find the coordinates of the vertices and yada yada. Okay, if my scale factor, K, is 2, am I going to be enlarging my shape, or reducing my shape? It'll be enlarging, right? Because it's 2 times bigger. That's what that means. Now, let's graph it. 0, 4. Let me choose a color you can see. 0, 4 is M. I want you to graph the pre-image, and I want you to graph the dilated image as well. The post-image. Sure. 4, N. I screwed up. M's not right there, is it?
Yeah, that's what I was doing.
Try again. See? I always mess up when I record it. That's my thing. 3, 4 is N. L is 3, 0. Pretend like those lines connect where they're supposed to. Of course, tricky. Okay, now I'm going to take each of those points and I'm going to change it by a scale factor of 2. When I change it, the notation M prime, is how you say it, N prime, and L prime. So we use the exact same letters. The little tick mark means I've changed the point. I've either rotated it or dilated it or transformed it or whatever. Yes. One size bigger, okay. It's been moved somehow. Now, how am I going to move it? I'm going to take each of these and multiply it by 2. So on your assignment tonight, I want you to draw the pre-image. I want you to draw the dilated image. And I want you to write the dilated point. Everything by 2. So 2 times 0 is still 0. 4 times 2 is 8. 3 times 2 is 6. 4 times 2, 8. Now when you're finished, you're going to get an image that looks just like the original, only bigger. So now we graph it. We plotted it, we found the new points, and now we're going to graph the new points. I want you to write this down, the new points, because sometimes, just like I just did, we graph things a little bit wrong, right? Remember when I put it here and I realized you were crazy? Even if you graph something wrong initially, if I see this part of it, I'll know that you understand what a dilation is. Does that make sense? So I do want you to write those down. Okay, plot the new ones. 0, 8, 6, 8, and 6, 0. Something-ish like that. Yep. It looks like the same image, right? Just bigger, twice as big. I wonder if I found the area, if the area would be twice as big. If I found the perimeter, do you think it would be twice as big?
Perimeter maybe.
Yeah. Perimeter maybe. Area? No. Probably not, right? Because area has like the squared in it. Maybe? Okay. I don't know. By the way, this is how math is invented. People just look at problems like this, they do something, and they're like, I wonder what happens if. And then they just start like discovering things. They start playing around with numbers, and then they make rules. Like that's how math is made. So y'all know. Okay, so that's it. Moving on. Next question. This one, scale factor is 1/2, which means what? I'm going to take each of these. I'm going to half them. Halving them is the same as what I'm doing right here. You don't actually have to write down. For this part, I want G prime, H prime, I prime, K prime. My original points are at 2, 8, 6, 6, 4, 2, and then -2, 2. In first period, I made a mistake on accident, because that happened. I think I'm going to make the same mistake on purpose this time, and you tell me what I need to draw. I want you to graph it too. There's just something, okay, maybe not for you, very satisfying of looking at it and being like, oh, it's the same thing, just bigger. I don't know, like, I just feel very good about it. So, half of 2 is 1. Half of 8, 4. What about H prime? Where is it going to be? I answered for myself, so you guys this time. Where will I be? 2, 1. And K? Okay, so let's graph this. So 1, 4. 3, 1. So that's what I did first period. Do they look similar? No, right? So I would go back and be like, Fred, where did I make my mistake? Where is the mistake? By the way, this was on purpose. Last period it was not on purpose. It doesn't look the same because this slope right here is not the same as that slope right here. So we have to go back. Where is my mistake? It's right there, right? I went over one down. It's supposed to go up. Now does it look similar? I make the mistake again on purpose this time, just so you can say, hey, I graphed it. It doesn't look right. Every time you get that, it doesn't look right, maybe you should double check your work, see if you messed up somewhere. Okay, any questions on dilation? Dilation always has to be on the what? Coordinate plane. If it's not on the coordinate plane, it's not a dilation. Really quick, there's one question on your homework. Let me see if I can find it. Oh, that's what I wanted. Right there. That has to deal with the pyramid and its capstone. This is the pyramid. This is the capstone. It's what goes on very top. The question is, are they similar? What do you think? Yeah. I mean, this slope, the face is slope right here, and then this slope is the same, and all of this slope is the same. Is the capstone similar? You would say, yeah, no, for sure, but I'm guessing it probably is. All right, Kendall, will you hit the lights for me? That's all. Thanks for watching. Peace out.